Hello and welcome, ladies and gentlemen. In this video, we're going to be doing something a little bit different than we normally do. Specifically, we're going to be exploring a few data files coming in a few different formats, looking at reading them into R and seeing how we can analyze them in R. We'll be doing a chi-squared analyses with all of these, but some of these are going to have some problems that we'll have to investigate how to deal with. Now, while this can be useful for your homework assignment and very well may be useful for an upcoming homework assignment, these are not going to be directly related to our course. So this video is a little bit of an odd duck in the way that it's not completely necessary. In any case, let's go on and jump into how we can read in data and analyze data using R. So the first thing that I'm going to do is make sure that I have all of the data sets downloaded. You'll see chi-squared data structure 1, 2, 3, 4, and 5. If you want to, you can go on and open these different data structures. You'll see that we're going to be studying some houses and whether or not some individuals would repurchase those homes. And our data are going to be structured in this way. This looks like a typical contingency table. In the second way, we're going to have the observations listed out where we have the different, this looks like an attempt at a long form of a contingency table. So we'll have to figure out how to read that in and use that. This is a true long form of categorical data where each row represents an observation. And so we can see that there's a lot of information contained in here, 360 rows. And we're going to have to figure out how we can summarize this information in a contingency table. In this one, it's the exact same situation, but a few of these have typos. So for instance, capital A frame and lowercase a frame are not going to be read the same. And so we're going to have to figure out how do we deal with typos in a data set. Finally, in the last case, I'm going to try to open it in Excel, but actually the file is not going to load in Excel. So I like this particular data set because this is a data set that literally doesn't fit into Excel. And Excel tries to fit, and you can see there's a lot of observations. I'm at 1,000 observations. I'm at 2,000 observations. I'm at 3,000 observations. And if you look on the right-hand side of the screen here, you'll see I'm at 5,000 observations, and this little tick mark has barely moved at all. So this is a data set of an actual legitimate size, and that data set doesn't fit in Excel. The fun part is if you try to fit in an Excel anyway, Excel still opens, but you'll notice the warning that it gave. The warning that it gave was this data set doesn't fit in Excel, not all records are loaded, which simply means that if you try to do analysis in a software like Excel, that analysis will not analyze all of the data. It'll just leave off the records that it couldn't leave in. So any data that's too big for Excel just gets ignored, which would be a pretty bad thing. All right, so each of these data sets are going to have their own independent issues, and we're just going to kind of walk through all of them. How I'm going to read these in, I'm just going to call them DAT1 through DAT5, and all of these are going to be read using the read.csv command. If you haven't seen how to read in data sets yet in R, I encourage you to check out one of our earlier R videos where we explain that. All right, so for read CSV, I'm going to use the dir command in R to look at the list of all the files in my current directory. Remember, if you don't know where things are, you can do the file.choose command, and this will open up a window where you can go select the file and get the full file path to your particular file. For me, my files are located in the same folder that R is looking in, so I don't have to list the full file path. I can just list the file name. But if you don't know if your files are listed in the same directory R is looking in, or if you just want to be extra safe, you can use that file.choose, find the full file path for your file, and then put those in for the read CSVs. For me, I'm going to copy in the first one, read.csv for that first. I'll do dat1 equals this read CSV. I'll run this read CSV, make sure things read in semi-appropriately. That looks okay-ish. And then I'm going to copy this line, and I'm about to read in 5 data files, so I'm just going to do all 5. The data files are numbered structure 1, 2, 3, 4, and 5, and then I'll just label them DAT 1, 2, 3, 4, and 5. And then I'll clear the screen. Oh, excuse me. I'll clear the screen on the right-hand side and then select everything and run all the things. You'll note that my data set that didn't fit in Excel took about a quarter of a second to load into R. So R is built for handling data sets that are larger than can it fit in Excel. All right, so I'm just going to go down the list of the data formats and we're going to address them as they appear with some of the different issues. Again, some of these are issues you might see in future assignments. Some of these are issues you might see when dealing with real data, and some of these are issues you may never see depending on the type of problem that you tend to work on. I hope that a combination of these issues and the strategies to address them will be useful for you if you ever are trying to interact with data. All right, so the first thing I do with a data set is I try to look at it. And this is a way to look at it. Another way to look at data sets that we'll talk about in the future is head, which just fills the first few rows. In this case, we only have a few rows, but in a case where I have hundreds of thousands of rows, and in fact, Excel can handle hundreds of thousands of rows, which meant that last data set had millions of observations in it, or millions of rows in it. I don't want to list out millions of rows. I just want to list out the first few and see how the data is being read. What I'll notice here in comparison with what we've seen in our previous chi-squared videos, like this contingency table looks pretty good, but this first column is being read as X and it's yes, no. So previously we had the row names being yes, no, but we didn't actually add a column with that label. So what we're going to do is we're going to make the row names be yes and no, and then get rid of that X column. Here's how we're going to do that. So I'm going to do row names of DAT1, and then we're going to write that. Now I could just write that as yes, no if I wanted to, or I can ask R to pull the first column. So the first column, I use square brackets and a comma 1. That pull, oh, excuse me, I need DAT1. Square brackets, comma 1, and that pulls the observations from the first row. If I did square bracket 1 comma, that pulls the observations from the first column. And if I combined both 1 and 1, that's the first row and the first column, this first entry here. For the row names, I want the entries in the first row. So I'm going to do DAT1, open square bracket, comma 1, and that'll make the row names for DAT1 the entries in this first column. All right, now that the row names have been set, I want to delete that first column. And the whole reason I'm doing this is I want everything inside of the data set to be numbers. And right now, this yes and no, this character strings or these letters are inside of my data set. Now I'm okay with them labeling the data set as a row name. I'm not okay with them being considered as data. So that's why they need to be deleted from the data set. Once I have the row names listed, I'll use the subset command, which is a way that I can take subsets of a full data. I'll use DAT1, and then I'll do the select command, and I'll do -X, which says get rid of X. Note that I'm using a capital X here to say get rid of the capital X column because it's labeled capital X. And if I used the lowercase x command and tried to run this, it would say, hey, lowercase x isn't found. Once this works, my data set should now be colonial, log, and A-frame house. Yes, no, and the only values in my data set should be numbers. I have column names and row names, yes, but in the data set, I only have numbers. I don't have these text anymore. I'll notice if I rerun this command, it'll still give me that error. It's because I already deleted the column and resaved it, so I don't have to re-delete it after it's already been deleted. From here, y'all, now my data set's perfectly formatted. I've got DAT1. It's a contingency table. It's ready to go in. And again, I'm just going to use my built-in test, chi-squared, test, DAT1, boom. I have my test statistic, my degrees of freedom, and my p-value. That looks great. All right, second data format. So that's coming in as a contingency table. Let's look at how this second one came in. So the second one comes in as a weird, like it's a long format, but it's not raw data. It's actually contingency table data. So it's kind of it gives the counts. It doesn't just list out 97 yes colonials. So that's nice, I guess. But it's not quite the format we'd like to see. For this one, to reformat it, I have to use a very, very specific command, and it's not one that you're going to see all the time, but this command is called xtabs. essentially what I have to do is I have to give it the number, and then I'm going to make a contingency table around the number by providing the columns and the rows. So I'm going to give it freak, that's the number. Then I'm going to give it a squiggle, and then I'll give it the rows and columns. So I want repurchase to be the row, plus homeowner to be the columns, and then I need to tell it where I'm pulling this data from. I'm pulling it from DAT2. This creates a contingency table. You'll note that the order of the contingency table is a little bit different. The order in XTabs here goes in alphabetical order because R is making the order, whereas in DAT1 it was going in the order that the data were provided. R didn't make those column names or choose the order of those column names. So for here, again, I need to save that. Maybe I'll call this, I don't know, ref DAT2 for reformatted DAT2. And once data is in this format, again, I just need it in the contingency format to run my chi-squared tests. So chi-squared test ref DAT2, boom, good to go. And again, this is the same data, just phrased in a different way. And once I get it into this contingency table format, it's the same. I do want to call out one thing. The data are, I want to be careful. The data are formatted slightly differently, even in the contingency table form, because of the order of the columns and the rows. So for instance, for A frame, the first number is 44 instead of 80, but that's because the no's come before the yeses. So if I look at what these data mean, and not just the numbers and where they are, but like what it actually means, this means that 80 people with an A frame house liked it. Looking at this table, if I try to figure out how many people with an A-frame house liked it, it's still the number 80, which is why it's giving me all of the same statistics. This is just in a bit of a different organized way. And it's okay to organize data in different ways as long as the meaning of the numbers don't change. So that's the big thing here. And don't stress about, R puts it in alphabetical order. That's not something to worry too much about. All right, let's look at the third data set. Third data format, DAT3. DAT3. Holy cow, there's a lot of observations. Wow, look at this. All right, so this is in a true long format. That is, each categorical variable has its own row that lists all of the different categories. So this first row is the first person. We went and asked, hey, would you repurchase your home? And they said no. And then I said, okay, well, what kind of home do you have? And they said A-frame. I said, great, thanks, have a nice day. And then I went and found the second person. And I said, would you repurchase your home? And they said, yes. And I said, fantastic. What kind of home do you have? And they said, I have a log house. And I said, great, have a nice day. And I went and did that with, golly gee, 360 different people. And that's how this data set is gotten. If you hand collect data, this is a very common format for categorical data to come in. And so it's really useful to know, how do I deal with data that comes in this format? Specifically, how do I get data from this format, a true long categorical data format, into a contingency table? Well, first of all, remember, if I'm dealing with data like this, I usually do head DAT3 so that the data aren't that overwhelming. Oh, excuse me, head DAT3 so that the data aren't too overwhelming. You'll see that in this case, I just see the first few records. I don't actually see all of the records, just the first 6, which is all I need. To see that, the column name is repurchase, the repurchase and homeowner, and this is the type of information that's in each one. Now, the main command that I'm going to be using with the 3rd, 4th, and 5th data formats, which are all long form categorical data formats, is the table command. So the table command, I'll do DAT3 $, and I'll just do repurchase. What table does is it looks at the different options and it counts how many people had the different options. Well, that sounds good, because remember, we need counts for a contingency table. So table is the command in R that does counts. If you're looking to do something like this in a software like, say, Excel, check out the pivot table command. That's what you'd be looking for. All right, so I'll look at the table of repurchase. Fantastic. So that's one variable. How do I do both variables? That is, how do I create a contingency table? And in R, it's super duper easy. I do dat3 $ repurchase, the first variable, and then dat3 $ homeowner. And this will give me a row and a column, and it'll count the observations inside of each. So I've got my A-frame column, my no row, 44 people have A-frame houses and would not repurchase it, and so on and so forth. And y'all, this is it. That's really it. That's my contingency table from a long, remember where we came from? We came from this bad boy. So how do I count all of the observations so I could get all my friends together for a weekend and do my fingers and toes and tally up all the numbers? Or hey, instead I could just use the that table command and it'll just do it automatically. That's pretty handy. All right, so I'll make a new data set called tab dat3. Remember, I can't do anything with it unless it's saved. I'll copy and paste this into there. So now I have those results saved, tab dat3. I can access that contingency table at any time. And if I want to do that chi-squared analysis, I'll run chi-squa.test, drop in tab dat3, and boom, I get the chi-squared analysis. You'll note that this is actually exactly the same as the previous data. This is the raw form of the previous data contingency tables that we were looking at earlier. All right, we are just cruising, aren't we? Well, we're about to get to a hard one. The fourth data format. All right, so this fourth data format, the third data format, again, a common way you're going to get it if you collect data by electronic survey or by like paper survey or hand, or again, if you just go talk to people and write down the results, that third format's very common. The fourth format is potentially even more common because the fourth is the exact same as the third, but it has errors in it. So let's talk a little bit about that. First of all, if I just look at these first few observations, you can see that this looks the same as the previous one that I dealt with. But what you'll see is different is if I do a table for one of the variables, I'll just pick that first one, repurchase, you'll see I now have three things happening here. I have a no, I have a yes, and then I have a lowercase yes. Yikes. So that means that one of the people who was typing this in when someone told them, hey, would you repurchase their house? We told everybody, hey, everybody use uppercase Y, yes, and uppercase N, no. And don't forget, and one person, one time when they typed it in, had a typo. And remember, R is case sensitive, so it treats capital Y, yes, and lowercase y, yes, as two different things. So if I analyze this data or try to make a table, it would assume that this is a categorical variable with three categories: a category for no, a category for uppercase Y, yes, and a category for lowercase y, yes. Well, that's not what I want. This was just a typo. So I need to fix this typo. The process of reformatting data and fixing data to be in the correct format for analysis is called data cleaning. Data are never clean. It kind of depends. And I mentioned different softwares require different formats. So data cleaning is a bit of a continuous process. It's just getting it in the format needed so that you can analyze it. In this case, the format I need is to fix the typo. This isn't a data set with three categories. There's only two options that we asked our participants. Do you like it or do you not? So I need to go in and fix that. There's a few things that we can look at, a few tools that we can look at to help. One is I can do which dat4 equals my quote with a lowercase yes. Equals asks the question, I need dat4 $repurchase. Which dat4 $repurchase equals yes. So I'm just going to highlight the inside of this which command. This is going to go and ask each of the observations in dat4. So if I look at dat4, here's all of my observations. And it's going to go in this first column and it's going to ask each and every one of these things, are you equal to yes with a lowercase y? And then the response is going to be either nope, false, I'm not equal to yes with a lowercase y, or true, yes, there's this one true amidst this whole list. Yes, I am equal to yes with a lowercase y. The which command says, I don't want to see all that. I just want you to tell me the number of the one that's messed up. So number 26 is the one that's messed up. So if I look at my data set again here, DAT4, and I scroll up to row 26, I can see, oh my gosh, well, will you look at that? Gosh, it's hard to see, but yeah, I guess that's a lowercase y. Yeah, okay, yeah, so that's it. That's a yes with a lowercase y. All right, yeah, it was right. So there it is, right there. And again, think about if you have to find this on your own, that would be a huge pain. I actually do this a lot with clients when they're like, oh my gosh, there's a mistake. I use the which command to say, hey, here's the mistake. Let me do one pause real quick. Again, the which command said row 26, so I went to that. If I go pull up the data set and I go to row 26, this isn't going to have that yes with a lowercase y. That's because in Excel, the first row is the variable name. The data doesn't start until row 2. So when R says which row is it, and it says 26, that's the 26th row of data. But in Excel, you have to add one row or more if you have column names. So if you have a whole bunch of header stuff up here, you have to realize that the 26th row of data is not actually the 26th row in Excel. So I have one column name. So the first row of data is the second row in Excel. The 9th or the 10th, the first row of data is the second row in Excel. The 9th row of data is the 10th row in Excel. And the 26th row of data is the 27th row in Excel. So my my lowercase yes is this yes right here. And again, if you look really, really, really close, maybe you can see it, that is a lowercase y. But gosh, imagine trying to find that by eye. That would be such a pain. So when you're looking in Excel, and again, if you use that which command in R, realize that that can be off depending on how much non-data information you have at the beginning. In my case, just having the row names, it means it's off by 1. So when R says the 26th data point, we can realize that's actually row number 27. All right. So we know which one it is. We could potentially go and fix that in Excel. And actually, that's something that's happened. I've worked with clients where I just send them the list. Hey, these are all the problem areas. Just go fix all those. And they'll go check all of them and fix them all. Typically what that is, hey, I need you to investigate all these to make sure they aren't errors. And they'll go and check them all out and fix whichever ones they need to fix. But for us, we know this is a typo, so let's go on and talk a little bit more about it. All right, so DAT4, remember I can go on and pull the 26th row. Oops. The format is the open close brackets, and then I need to use a comma to indicate that's what I missed here. I need to use a comma because I need to tell it the row and the column. The row comes first, so 26th row. If I don't include a column, it'll show me all of the columns. So this is the 26th row and all of the columns. And again, I can confirm that that's where the yes is. Now, what I'm going to do is I'm going to be very, very specific. The 26th row, the first column, that is this exact record. And what I'm going to do is I'm not just going to look at it. I'm going to reassign it. So I'm going to use that arrow, and I'm going to put in place of that lowercase yes, a capital Y yes. And that's actually going to change that value. So if I re-look at that value, DAT4, 26, 1, now that value has changed from a lowercase yes to an uppercase yes. And that's all it takes to fix it. I just have to go find the one where it is, change it to be something different, and now it is changed. So if I rerun that table of observations, I can see no and yes, those are all good to go. I have only 2 categories. It wasn't the numbers that was wrong, it was the categories. Again, in the previous table, it had 3 categories: no, lowercase y yes, and uppercase y yes. Now it only has the 2. So, whew, that was a lot. All right. Well, I'm good to go. All right. So, table DAT for repurchase, DAT for homeowner. Man, I'm so glad I'm... Uh-oh. wait, look at that. Not only did I have a typo in my repurchase, it looks like I have a lowercase a frame and an uppercase a frame. And y'all, I did that intentionally. You know why? Because that's how life is. Life is, you think you got it all good, and then you rerun it, and you're like, oh my goodness, I've got more to do. And that's completely what we have here. So let's jump in. We're going to have to clean this homeowner variable too. And so let's go on and clear the screen and really focus on that homeowner variable alone. I'm going to do a table dat for $homeowner to pull the homeowner variable information. Here I see I have lowercase a frame, uppercase a frame, colonial, and log. It looks like, based on colonial and log, that this is supposed to be an uppercase a frame. But y'all, now there are 20 values. So I can still do that which thing, which dat for $homeowner equals lowercase a dash frame. And these are all of the ones that are A-frames in R's thing. Now, if I sent this list to a client, I might be nice and go up and do a +1. Remember, the 9th row in the data is the 10th row in Excel. So the little +1 would give these all the Excel rows. Even there, though, this is a lot of stuff to investigate. And if I had to go and change the 9th row, the 10th or the 12th row, the 54th row, the 74th row, the 95th row, that would be a real pain. Has this happened? Absolutely, this has happened. What happens here is one of our data collectors forgot to do the capitals for all of them. So there's a couple things you can do. You can do like a find and replace in Excel, depending on the problem. You could go and manually change them in Excel. You can manually change them, as we just showed how to do in R. But what we'll show you how to do real quick is how to systematically change them in R. So remember, a lot of places that you can put numbers, you can put a list of numbers. So I'm going to say wrong row. And this is going to be a list of these numbers that the row is wrong. So these are the rows that I have a wrong A-frame listing. So I'm going to look at dat4, and in the row number, I'm going to do wrong row. And I'm going to give it all of these numbers instead of a single number in the row. And this is going to give me my data set, and it's going to give me all of these values with the wrong value for homeowner. And so if I look at homeowner, I can see all of these, yes, have the lowercase a frame. The repurchase is correct. We already fixed the repurchase values, but for homeowner, all of these ones are the wrong ones. Now, if I kind of followed the process above, what if I just pull the second column that is just the wrong ones in this? Oh, well, that'll give me a list of all of the bad values. Okay, perfect. Can I do the same thing as we did previously, where I just switch all of these to a capital A, capital F, A-frame? Yeah, you can. And now if I look at all of these again, whereas all of these were the wrong one, now all of these have been updated. And if I do a table of dat $homeowner, or excuse me, dat for $homeowner, I can see that that fourth category of the lowercase a frame is now no longer part of this. And so I just updated all of this all at the same time. So I can update a whole ton of different values very, very, very quickly. All right, well, now let's go and check out this table of both together. I see that this table of both together finally looks correct. I have 3 different styles of house. I have no's and yeses. Thank goodness. So now I'm going to go on. I could resave this table as a variable, but you know what? You can just copy and paste the table, and I can do the chi-squared test, and then I can just paste that table command directly into the chi-squared test. And you'll see after cleaning up this data set with all those typos, I get the exact same result as I was for all the previous ones. Heck yes. Woo! So that's a lot. That's a pain. But to be honest, this is what it's like to deal with real data. It's a lot of problem solving. It's a lot of figuring out where are my problems. It's a lot of figuring out what are the problems. Quite frankly, we don't do a lot of this in class, but in a professional environment, a lot of this is working together. I really do send clients long lists of numbers to say, hey, y'all, these ones look kind of funny from my end. Say, they look like they've been written differently. I don't know why. Maybe these are just typos, but hey, maybe go in and check that lowercase a frame is the same kind of house as uppercase a frame. I don't know anything about houses. And that's kind of the fun part of being a data analyst is I don't always know the stuff about what I'm analyzing. I just kind of have to analyze it anyway. So kind of fun stuff. All right. So let's close out by looking at the fifth data set in R, the fifth. And I'll call this big data. I'll say that if you've ever heard of big data, that used to be a buzzword a few years ago. Still kind of is, depending on who you ask. But big data really depends on who you talk to. Back in the day, you could say data that didn't fit in Excel. That might be big data. And then it became, data that was bigger than a gigabyte. And then it became data that couldn't fit on your computer. And now it's just dumb amounts of data. So big data has definitely changed in name. And in a practical way, those different scales of data invite different analytic approaches. So R can handle big data, certainly bigger data sets that can fit in Excel, but R is probably limited by the amount of RAM on your computer. There's different tools that you can do to analyze bigger data sets that maybe fit on the hard drive, not the RAM of your computer. And there's different tools that you can use that take multiple computer hard drives to do it. Now, I will say R integrates well with these tools. So typically what I do when I deal with really, really, really big data is I use the commands in those tools to pull the data that I'm interested in into R, and those sub-data sets are smaller, and then I do my analyses with those sub-data sets. But there's a ton of different tools out there for those different methods. Now, I will say too, how often do you deal with those size of data sets? Well, depending on the company you're at, relatively rarely. If you're at Amazon or Google and you're in their analytics department, you're going to be dealing with that many, many, many times per day. But if you're at the local bank, you may never deal with a data set that size. You might deal with something that breaks Excel, but you'll never deal with something that doesn't fit into R. So for me, I have yet to deal with, that's not true. I deal with a few data sets that fit in R, but I have yet to deal with any data that can't be analyzed in R, at least at some point. In any case, it's kind of fun for you to see and to be able to say that you have analyzed data that didn't fit into Excel. And honestly, that's the whole point of this fifth data format. It's not dirty. We've already taken the time to clean up dirty data, so this one's nice. So let's look at head DAT5. All right. I also want to look at dim DAT5. Dim pulls the dimensions, the number of rows and the number of columns. So you can see this has 1,048,577 rows, which is, I think, just like 2 or 3 too many to fit in Excel. Again, I made this data set just so that we can say that we've analyzed data that doesn't fit in Excel. All right, well, let's go on and run our table. DAT5, $ repurchase, DAT5, $ homeowner. And honestly, y'all, again, for a data set that has over 1 million observations or over 1 million rows, more than that observations, over 1 million rows. In this case, you can see that R can almost instantaneously create a contingency table for categorical data, even in data sets that are that large. And again, it's very, very, very handy when you were dealing with data of multiple different sizes. So R is just a fantastic tool for that. I love it. It's one of the cool things, and congratulations. Now you just created a contingency table in a data set that couldn't fit in Excel. All right, I'm going to copy and paste that. I'm just going to do my chi-square.test, paste that into there. And hey, now you just did a statistical analysis of a data set that didn't fit into Excel. Congratulations. I have my chi-square test statistic, my degrees of freedom, and my p-value for this data set. Very, very cool. All right. Well, yeah, this video's gone kind of long, I suppose. All right, let's add one more thing on here. I don't think I talked about this in the main videos, but it is kind of handy. So let's go on and add it. Follow-up testing. I mentioned follow-up testing, but I didn't show how to do follow-up testing. I don't think we do that in this course specifically, but it is kind of handy. So what I'm going to do is I'm going to work with the first data set. So that is DAT1, and that's just my first contingency table. And I'm just going to work with this because it's small, readily available, and quick to use. The first thing I'm going to do is for each of these, I'm going to find the totals for each of the problems. So again, if I'm calculating a probability, and we talked about finding probabilities and doing pairwise comparisons of probabilities in the lecture notes, if I'm finding the probability, remember the probability is the number of people with the characteristic divided by the total number of people. So right now, for each of the houses, I'm going to find the total number of people using the apply command. I'm going to do column-wise sums, and this is going to find the totals for each of those columns. Now again, we did this for calculating the expected value for a chi-squared. I'm doing something completely different. I'm, for colonial, about to put 97 over 135 to find the proportion of people who liked a colonial house. My successes, I'm going to do the DAT1, and I'm going to pull the first row. And so this would potentially work. I want to do two things to this, though. Instead of just pulling the first row, I'm going to give it a little bit more command. I'm going to tell it to pull the row labeled yes. So I can give it a number which says pull the first row, and that works here, but I'm going to tell it to give me the row labeled yes, because remember, in some of these contingency tables, once I had the table made, the row labeled yes was actually not the first row. Now in DAT1 it was, but it's not always the case. If I tell R instead, give me the row labeled yes, then it's always going to get it right, whether the first row is yes or not. The second thing I'm going to do is a little bit weird, but I'm going to wrap this all in an as.numeric. What this is going to do is that the current format, when I pull out this information, looks like a matrix. But instead of doing that, I'm going to keep the, I'm going to force the type of data to, instead of being a matrix row, be a list of numbers. The apply already counts as a list of numbers, but down here, if I didn't wrap it in an as.numeric, it would get a bit confusing. With this said, for the as.numeric, I do still want to keep the names of the columns. So I'm going to do names of the successes to be the call names of DAT1 so that I can keep, oh, I didn't run the suck for successes. So I can keep the labels on each of these. All right. So now that I have this, essentially I have a vector of the number of successes and a vector of the number total. The command to run the pairwise test is pairwise.prop.test. And I give it the number of successes and I give it the number of totals. You'll see what this does. This gives me a table of p-values for the comparisons. So if I look at the comparisons between a log house and a colonial house, the comparison of the proportions, the p-value is 0.18, which means this is not significantly different. If I compare the A-frame house to the colonial house, the p-value is 0.257, which is not statistically significantly different. And if I compare the A-frame house to the log house, the p-value is 0.015, which is statistically significantly different. So if I come back from my chi-squared test, and I believe we did if I did the chi-squared test on DAT1, and it says, yes, there is a statistical significant difference between the people who like their, or statistically significant relationship between the people that like their house and the type of house they have. There is evidence that those are not independent, that it does depend on what type of house you have to determine whether or not you like it. So there's a relationship between those things. The question then might be, if we're looking at this as a test of proportions, well, which proportions, which house has a higher proportion of people who like it? And this follow-up method would suggest that it's the A-frame and log house that are significantly different from one another. If I look at this, I can see for my data, the, well, I guess I can't see it easily from here. I could do, I'll just calculate this real quick. Suck over tote. Guess I don't have it easily there. Here in my suck over tote, the variable names are getting weird. This is the proportions of people in each who like it. So the proportion of people who like the colonial house, 71%, proportion of people who like the log house, 82%, and proportion of people who like the A-frame house, 64%. So A-frame and log house were significantly different than one another. Which one was higher? Well, the log house was higher. What that indicates is that my follow-up test tells me that significantly more people prefer a log house than an A-frame house. All right, I know that was a bit of a weird direction to take that and a bit of a weird way to end. But in this video, we really talked about how to deal with a whole ton of different types of data sets coming into R and how to manage them so that we could still do our analysis with them. In addition, we talked about how to deal with data sets that came in that had mistakes in them and how we can correct them using R, or simply identify the mistakes using R and then send out a list of which rows are likely to have mistakes so that we can review in Excel or so that others can review in Excel. Finally, we dealt with how to analyze a data set that could not fit in Excel. We created a contingency table for that data set, and we calculated a chi-squared test of independence using data from data that were too big to fit in Excel. You just did that. Congratulations. Kind of fun. Last but not least, we did a kind of random bizarre tack on of some proportions testing, a follow-up test of proportions, something we mentioned in the lecture but didn't really cover in the videos at all. In any case, ladies and gents, thank you so much for sticking with me through this video, and I will look very forward to catching you in the next one.